Hello guys, welcome to Math City with Miss G. Today we are going to talk about addition and subtraction of rational expressions. I have here examples of expressions that has the same denominators. I've got the steps on the right hand side. Let us focus on one problem at a time. Okay, so for the first problem, we have denominators that are exactly the same, 8p, and an operation that's positive. So if this is the case, this is one of the easiest problem we are going to be solving. So we are going to write the common denominator, which is 8p, and we can rewrite the numerators and put the variables that are alike right next to each other. So I can start with m plus 6m. You do not have to do it this way, but you can also put them side by side so you can see visually what happened. Now I'm looking at the p's, minus p and minus 3p. So we have here variables that are the same, so we can combine like terms, and so this will be 7m minus 4p over 8p. Now, be mindful that the numerator is separated by a minus sign, and since that is the case, we cannot simplify anything here. So therefore, this is going to be our final answer. Let us try working on number 2. For number 2, we also have the same denominator, so we can write the denominator as 1, so 6m cubed n. Be mindful that the numerator, the second numerator, is a binomial. And then before the second fraction, we have a subtraction sign. So if this is the case, put a parenthesis around the binomial. Why? Because the operation before this expression is a subtraction. This would mean we will be distributing that minus sign into each term. So that will become m minus 3n, and as we distribute the m, this m here is going to be a minus m, and then we will have minus 3n. We're going to combine like terms. We will end up canceling m minus m is 0, and then we got negative 6n over 6m cubed n. So I don't see any plus, no minus sign, therefore it is okay to cancel common variables. Right, so I'm looking at n and n, and as well as 6 and 6, and so our final answer will be negative 1 in the numerator. Nothing is left, but we can't leave that blank, and we can't certainly put a 0. So that is going to be negative 1 over m cubed. Okay, let's move on to another problem. Let's take this to another level. So if you see something like this where the denominator is a trinomial and can be factored, we are going to factor the denominator first. So our leading coefficient is 4. And because it is 4, I will be using split the middle process. So we cover this in quarter 2. So if you notice, we have a, which is 4, c is negative 6, so we'll multiply a times 6, a times c, which would be 4 times negative 6, and then b, which is 5. So we are taking the coefficients of each expression. So a is 4, b is 5, and c is negative 6. Right, so 4 times negative 6 is negative 24. Drop the 5. We're looking for factors of negative 4 that when added is going to give us positive 5, and I believe that is going to be negative 3 times 8. So negative 3 plus 8 is 5. It checks the box. All right, so let us split the middle. So this would be negative 3x and a positive 8x. We are going to drop the first term, 4x squared, drop the last term, minus 6. Now, remember, we have 4 terms. So we are going to factor this by grouping. Group the first 2 terms, group the last 2 terms. We're gonna take out GCF if there is a GCF. So the first term group, we have x as common. Factor, we take it out. We are left with 4x minus 3. The second group, we have a common factor of 2. It's positive 2. I've got to put a plus sign. And we are left with 4x. We take out 2, 4x minus 3. So we come up with exactly the same expression, 4x minus 3, and they're meant to be the same. And that is going to be our new GCF. So we write it one time, 4x minus 3, and the previous GCFs, which is x and 2. We'll put them together, x plus 2. So here is the factored form of the denominator. Now, we are going to write that expression, our answer, in the denominator, 4x minus 3 and x plus 2. Okay, so the denominator must be in a factored form. Now, the numerator, there's no x squared over on this side of the expression. So I am going to simply copy this over here. So x squared. I can't combine that to anything, add it or subtract it. While I am looking at 5x minus 3x. So that is going to be positive 2x. So the numerator, x squared plus 2x, has a common factor of x. So let us factor out x. So x, if we take out x, we are left with x plus 2. So we factor all the way. We drop the denominator, 4x minus 3, x plus 2. Okay, so notice that we have the same, there is an expression that's exactly the same in the numerator and the denominator. Because they're exactly the same, then it is okay to cancel this. Why? Because each is separated by multiplication. So this will leave us with our final answer, which is x over 4x minus 3. And since our denominator has a variable, we have to identify the excluded value, meaning what number that will make the denominator equal to 0. And what would that number be? So I will take this exact denominator, which is 4x minus 3 equals 0. Isolate x. So 4x equals 3. So therefore, x is equal to 3 over 4, meaning the value, the excluded value is going to be x cannot be equal to 3/4. So you might be asking why. If we substitute the answer, the number 3/4 in the expression 4x minus 3, and we substitute that where x is, okay, so we are going to have something like this. When we simplify, we've got 4 numerator and a 4 that is denominator, so we can cancel that out, and we're left with 3 minus 3, which makes it equal to 0. So remember, we cannot We can't make the denominator equal to 0 because that will make the expression undefined. So we've got to include the excluded value. All right, let us take this to another level. Okay, so this time we are going to add and subtract rationals with different denominators. Okay, so I've got the steps over on the right hand side. I am going to explain this to you one at a time. Let's zoom in. So number 4. Okay, so when the denominators are not the same, we are going to make it the same. How do we do it? Okay, so if the denominator is a binomial, I'm looking at x minus 1, that's a binomial. We're going to put it in parentheses. Okay, so I'm looking at 4. Okay, so we're going to use 4 and multiply 4 in the first fraction, top and bottom. Okay, so we're trying to make the denominators the same. Now, the second fraction will be multiplied with the first denominator. So I am going to write 4 gets multiplied with x minus 1 and as well as the numerator. Okay, so notice whatever we're doing right now, it makes the denominator the same. That is the purpose of what we are doing. Okay, so we are going to write the denominator one time. So 4 quantity x minus 1. Okay, so we're going to simplify the numerator. 4 times 6 is 24. And we have a minus sign. We've got to be careful with minus sign. Okay, so that is a minus sign. So we drop minus sign. We distribute 5x times x. That is 5x squared. And then 5x times negative 1 would be negative 5x. And remember, this is a binomial, so we've got to put that in parentheses. Okay? And now we're going to distribute the negative sign. All right, so that will make, okay, so 24 minus 5x squared. Distribute the negative to the second term. So that will become plus 5x. We drop or copy the denominator. Okay, so the numerator has no GCF, so we can keep that as our final answer. However, we're going to write our numerator in the standard form. So highest exponent from highest exponent to the least. So negative 5x squared plus 5x plus 24 over 4 quantity x minus 1. And that would leave us as our final answer. Okay, let us try another problem. Number 5. Okay, so our denominators are algebraic expressions, binomials. First step is to make the denominators the same. And so the first denominator gets multiplied by the second denominator. Second times 2n plus 6. Same thing up on the numerator, 2n plus 6. And the second denominator gets multiplied by the first denominator, n plus 5 times n plus 5. So the numerator and denominator gets multiplied by exactly the same. Okay, so what is the purpose of doing this? We are making the denominator the same. Okay, so let's write it down. N plus 5, 2n plus 6. And then we're going to simplify the numerator, distribute 5. So that would be 10n plus 30. The operation in between the fractions or rational is an addition. So therefore, I don't have to worry about changing of signs. So I will have, when I distribute this, that would be plus 4n squared and that would be plus 20n. Okay, so focus on the numerator. So in the numerator, we have something here that we can combine. Okay, so 10n and 30n. That will give us, 20n. So that will give us 30n plus 30 plus 4n squared over n plus 5 and 2n plus 6. In the numerator, if you notice that we have 30, and 4, there is a GCF, so we are going to take out the GCF of the numerator. So let's focus our attention to this part of our answer. So, I believe we can take out a GCF, which is 2. So if we take out 2, we are left with 15n plus 15 plus 2n squared. The denominator, because I am taking out a GCF, so I am going to double check my denominator, and I am focusing on this. So there is a denominator for, a GCF for the second denominator. So I am going to take it out, and that both the 2 and the 6 is divisible by 2, or the GCF is 2, we'll take it out. So that will leave me with n plus 3. And then I'm just gonna drop over n plus 5. So I'm rewriting the denominator, okay? But instead of writing 2n plus 6, I'm writing 2n. 2 quantity times n plus 6. So if you distribute, it should go back to 2n plus 6, okay? Now, we have here a common number, okay? So we've got a 2 on the top and a 2 on the bottom, therefore we can cancel those two together. And so it will leave us with our final answer, and that would be, let's arrange it in the standard form. So we start with the highest exponent, all over n plus 3 and n plus 5. Again, keep the denominator in factored form. And there's our answer. Okay, let us try one more problem. Let's take this to another level. How about if we are given with this type of problem? How do we solve this? Okay, so I am looking at the second denominator. Okay, so that is a trinomial with a leading coefficient that is 1. So we can simplify or factor x squared minus x minus 20. Okay, so because the leading coefficient is 1, so we can go directly with using CB. And C is negative 20, B is negative 1. Okay, we're taking the coefficients. So A is 1, B is negative 1, C is negative 20, all right? So let's look for factors of negative 20 that when added gives us negative 1. I believe that should be negative 5 times 4. Negative 5 plus 4 is negative 1. Checks the box. Okay, so we are going to go back here, and I'm going to just cross this out. I'm going to try to save a little bit of space to not write the whole thing over. So we can write x minus 5 and x plus 4. So that is going to be the denominator that we are going to consider at this time, the factored form. Okay? Now, what do you notice? Okay, so I'm looking at x minus 5 and x minus 5. They're exactly the same. Okay? Now, focus your attention on the denominator that is not common. So x plus 4 is not common. We are going to use that exact number and multiply, that expression, and multiply that to the first fraction. So we are going to multiply x plus 4 and x plus 4 in the numerator as well. second fraction will not get multiplied because if you take a look, our denominators are now exactly the same. Okay, so we are going to bring over x minus 5 and x plus 4. Okay, so the numerator, let's distribute 1. So obviously that's going to stay x plus 4. And the operation in between the rational expression is addition. Because it's addition, then I don't have to worry about any changing of signs. So I'll just drop the positive 2x and drop the negative 19. Okay, so let's simplify the numerator, combine like terms. So we'll have 3x minus 15. And we are going to drop the denominator, x minus 5 and x plus 4. Okay, focus your attention in the numerator. So our numerator is 3x minus 15. Okay, so there is a GCF, and we can take out 3 in this expression. So we'll take out 3. We'll have x minus 5, and we're going to drop the denominator. Okay, now notice that we have the same expression, x minus 5 in the numerator and x minus 5 in the denominator. Therefore, our final answer will be 3 over x plus 4. And because the denominator has a variable, therefore, we've got to identify the excluded value. And that would be x cannot be equal to inverse of positive 4 is negative 4. Because when we substitute negative 4 to x, it will make the denominator 0, which we are trying to refrain from. Okay. Thank you guys for watching this video. I will see you on my next one. Bye.